So let's go to you, Matt. And Stan talked about one flavor of denial of service attack, and actually this might be sort of a little bit related, right?
Sort of a little bit related, sure. So this is a pretty fascinating story. There's an organization called Great Fire. They're an anti-censorship organization that focuses mostly on the censorship within China. And as such, they're a regular target of Chinese interest, we'll just say that. Recently, their website's gone under DDoS attack, and shortly thereafter, some of their pages on GitHub were also under DDoS attack by a huge amount of attackers. And now GitHub is calling this the biggest DDoS they've ever seen. So this is significant. The interesting part about the attack is the sources of the traffic, because it seems that these are just normal users. And through a little bit of investigation, Great Fire has shown that the sources of the traffic are visitors to websites that have assets that use Baidu, which is a Chinese search engine. They also have something called Baidu Analytics, which is similar to Google Analytics. If you're a website owner, you insert a little bit of JavaScript code in your site, and it tracks usage of the site for you by your visits. Apparently, somewhere along the path between these users' computers and the Baidu servers, that Baidu Analytics code is being intercepted and replaced with JavaScript that causes a number of requests to be made against these target servers.
Bizarre.
Really bizarre and kind of amazing. Yeah. So from what they've reported is that about 1% of users are being redirected, at least that bit of the code is being redirected to this attack code. It's being basically manipulated in line. And so the assertion there is that this is some aspect of the Great Firewall being used to not just censor traffic, but actually actively manipulate it to turn visitors to sites into DDoS participants, which is a pretty hefty claim.
Yeah.
But it also kind of
unknowingly.
Ongoing.
Unknowingly.
Oh, unknowingly. Yes, this is true. Well, that's a good point, because GitHub, I guess, has been in communications with Great Fire, because it was, GitHub's hosting the content. It belongs to Great Fire. They've been coordinating. GitHub has actually inserted their own warning messages into sites. So if you end up at Baidu and that attack code is in there somewhere, it makes a request to GitHub servers. And what will happen is the request to GitHub will come back with GitHub's own injected code that says, you're visiting a site that may be compromised. You should probably worry about this. Now, these are all plain text sites. If you were using SSL, you probably wouldn't have this opportunity to inject the code in there, which, if you want to use that as an excuse to start saying people should start encrypting everything, that's one argument for it.
Yeah, that's a good point. I think the thing that boggles my mind here is, we talk a little bit about attribution. Now, this is a case where I suspect the attribution has a lot to do with circumstantial information or evidence, as opposed to, you can't, how do you trace that back? How do you define who the attacker is in a case like that? Well, that's a really tricky one.
The interesting part is somebody actually has done it, and that's URL query, which I know we're all familiar with. Is a website that if you go to it, you browse to it, you give it a URL, it'll go and check it out. Apparently, it passes through that same sort of, whatever manipulation is occurring, and their logs indicate the contents of that JS file that keeps coming back, and they can see this is the attack code, and this is the site I tried to visit, and this is what came back.
Right. Okay.
So it shows the manipulation in action.
You can see that, but where did the code come from? How do you know?
Well, there's no. Yeah, that's the thing. I don't think there's any. I'm not clear on this. There may not be a particular server that it's reaching out to get. It may exist somewhere in the memory of the devices that are doing this inline manipulation. In which case, you're right. You wouldn't have evidence anywhere but in these interstitial devices.
Yeah. Certainly a tricky one. I don't. This is. I think it just really kind of broadens your mind in terms of the levels of indirection and tricks that can be
It was interesting to me the strategy that you said GitHub took with the re-injection of other code back to the users.
Well, it's their own site. They can return whatever they want to. So if you've ever been to a website where someone was hot linking an image, and it would eventually be replaced by this site is not authorized to use this image, they may be using the refer
Similar
header,
technology, something like that.
something like that, to figure out where the request is supposed to be coming from, and say we need to worry about this. Return something different.
But it's
So-
a very creative solution, I think. Well, you know.
It's in general, it's a pretty creative solution on both sides. The one thing that worries me is that you've got, but if the claims are true that this is 1% of the traffic, imagine if 100% of the traffic was manipulated. Take any major website, and then if you can own the infrastructure around it, and you can inject your own content into what comes back, you can turn any visitor into an unknowing participant in an attack
Right.
at huge scales.
Yeah, I wonder how scalable it is. Yeah, you got to imagine if it was really true that that could be done, it's probably not trivial to establish that at scale. Maybe they figured it out.
Well, and I think part of it is going to be understanding what's going on is, I think, an important part to be able to generate a defense against it. So this is, I think this is something that's probably worth some additional investigation and how it could develop going forward.